Wednesday is your Unit 3 test. Unit 3 test, quite certain, is not going to be extending outside of our class period unless you just decide to camp out on one question for 20 minutes. I really think that if you are on top of it, 50 is fine. 50 will be just fine. Again, just based on my own timing. Definitely faster than the other two. And then we're working here, of course, this has disappeared. Let's pretend for 1 second that example number 1 was right off of some quiz or test or the AP test. Let's run through some of the things you might do. You would recognize, first of all, that, of course, it is a fraction. So what might be the first thing you think about? I like to think about something else first, just me personally. Flip up would be one of it. I always think of ln first because, for me, I can do that in my head. So what I would be thinking if I was thinking about ln is the derivative of the denominator, the numerator. I can usually tell this pretty quick, right? You can too. So 2x minus 5, numerator completely off, right? It's not even close. Timmy didn't just butcher it. He has the wrong form, right? So it's not ln. So I think to myself, all right, ln. And then the next thing I'd think of, I think Meg's idea is good. Let's flip it up. See what happens. This one, sometimes I'll write it out. I get this x squared minus 5x plus 6 all to the negative 1. And whenever you've got a big quantity to the negative 1, warning bells should be going off in your head, because what's about to happen? Yeah, something over 0, which should probably lead you back to ln, but you already showed that it's not ln, right? So as soon as you see something like that, you'd say, well, I don't think it's flip up. All right, so then we think arc, sine, or arctangent, and we've done these, right? Because you look at that and you say to yourself, that does not look like arc, sine, or arctangent. But if it was going to be one of the two of them, which one would it be? Because there is no what symbol? There's no square root. So what might we do here? Yeah, let's try it out. So x squared minus 5x, and then the plus 6 is out there. This b term is odd, so it's a little bit awkward, but we can do it. What's half of negative 5?
2.5.
Let's do fractions. That'll make it easier. Square it.
25.
So I go plus 25 over 4, but then I have to go minus 25 over 4 out on the outside, right? Okay, so this is kind of looking like maybe this is going to be arctangent after all, because when I factor this, I get x minus 5 over 2 squared. And then what's 6? Positive 6 minus 25 fourths?
Negative 1/4.
Ouch. He's right. Why is that ouch?
Because you can't take the square root of negative. It's not real.
Yeah, we've now gone into unreal numbers, right? Because isn't this supposed to be, if this is going to be arctan, isn't it supposed to be u prime times a over a squared plus u squared? And I've got u squared minus a squared. It's like something's off, right? So as much as it looked like it was going to be arctan, it's not that like I get to choose ln today because I just feel it's like an ln kind of a day, or tomorrow feels like an arctan day. It's either one or the other, or it's something else. But we can't just pick because we feel like it. This just doesn't work. So we knew it wasn't arcsine. We now know that it's not arctangent. And at this stage, if you were being honest, you'd have to say, well, gosh, assuming I didn't make any arithmetic errors, I don't have a clue how to do this. Do you see how you could arrive at this place? Say, I've tried everything. I've tried all the stuff I know how to do, all the stuff that made sense, and none of it worked. So what do? So you could, but that's not what somebody like you would do, right?
Never.
I sure hope not. What you would do is you'd realize that our final technique of the year for integrands has arrived. And yeah, it's the final one. And it's called partial fraction decomposition.
Oh, wait.
Partial fraction. So can you go back in time to the not so far off past, or maybe for some of you the far off past, and remember back to a time in pre-calculus, for sure DC pre-calculus, where you did this partial fraction breaking apart thing, right?
No, I hated this.
So hold on before now listen. There's always stigma associated with things sometimes, and just like, think about this for a second. Can you imagine how bad it would be if if a teacher's first impression of a student was based on the behavior of a student who had the same first name like in a previous year. Like let's say, for instance, 9 years ago I had a student named Julia, and Julia was not a pleasant person. And as tried as I might to be nice to her and teach her and help her with whatever she needed, she just was really unpleasant and just never seemed to go very well. Well, then new Julia walks in my room and I find out her name is Julia. How bad would it be for me to say, oh, it's Julia, right? And prejudge her just based on her name, right? I mean, that would be silly and dumb, and I would not want to do that. So let me encourage you. Whatever stigma you have, I'm just like, I knew Aiden or somebody was going to say, oh, let me just point something out to you. This partial fraction decomposition, scary as that sounds, is going to be the easiest possible version of this. It's the easiest version. It does not get any easier than this when it comes to partial fraction decomp. So you will only have non-repeated, distinct linear factors. Okay, so this makes a huge difference because if you've got repeated linear factors, that adds a layer of difficulty. If you've got irreducible quadratic factors, that adds another layer of complexity and so on and so forth. We're going to bring it all the way back to the super simplest version of this, non-repeated linear. Okay? So maybe suspend your, I hated this thing. And I think you'll see that it's actually not that bad. I really do. That's usually the reaction I get. Like in 5 or 10 minutes once we've completed number 1, usually people are like, that's it? I'm like, yeah, that's it. And they're like, okay, good. I can do that. Versus the, torture fest of this other stuff. Okay, so here we go. You understand, we looked at all the possibilities here. You understand that none of our options works. We go with this partial fraction decomp situation. And so what I need to do first is try to find the factors of the denominator. So this is regular old quadratic factoring from back in like Algebra 1 times. What factors work out here?
2 and 3.
Not just 2 and 3, minus 2, right? And minus 3. Okay. So maybe you remember this. This is one of these algorithms, one of these processes that will be consistent. So I want to show you how to do this. I usually do this off to the side somewhere. What I'm going to do is I'm going to say 1 over x minus 2, x minus 3 equals a over x minus 2 plus b over x minus 3, where a and b stand for some numbers, some constants, right? Like 7 or -9 or whatever they might be. So basically what I'm trying to do here is ask myself, how do I take this fraction that has been put together and break it apart into a sum or a difference? How do I uncommon denominator and add it? Does that make sense? Split it back up. All right, so here's how we do it. Step 1 beyond this is to then get rid of all my denominators. What would I need to multiply by to get rid of all the denominators?
X squared minus 5x.
Yeah, you could multiply by the product of it, or you could just list the factors out. I'm going to list the factors out just to remind myself what is and what is not going to cancel out. So as I multiply this through, certain things will cancel, certain things won't. So for the first one, I'm just going to get a 1. What would I get for that second term? Just x minus 3?
Ax minus 3.
There'd be an a there as well, right? So a just stands for that constant, and we're going to be finding here in a minute. And how about the last term? B times x minus 2. Okay. So far, so good? So what we need to do now is we need to figure out what the a and the b are, and we'll have to do it in 2 steps. So what I'm going to put out here is this. I want one of these to go away, and I think I want the b to go away first. So I'm going to say if x equals 2. Think about what would happen if x equaled 2. The coefficient on the b would become? 0. This is handy because what I can do is say if x equals 2, then 1 equals a times 2 minus 3. Therefore, a equals what? A equals -1. You're right. So all I really need to do here is find the a and the b, and I just found the a.
Okay.
What would I need to do to find the b? I'd need to set the x equal to what? Say again?
3.
3, yep. So if x equals 3, I would get 1 equals a times 0, so just 0, times b times 1, and look at that. Doesn't b equal 1? Let me just pause for a second. Do you have any questions like, why are you doing this? How are you doing this? What does this mean? Anything like that? Doing okay?
Why? Wait, why can you just plug in 2 and 3?
You can plug whatever numbers you want in for x as long as you plug them in for all the x's. We're just basically evaluating. Frankly, you could plug a number in for a if you wanted and just see what happens. It wouldn't really be beneficial for us. But I can plug in any number I want for x. As long as I do it in both places, it's still true, right? As long as I substitute in both places, it's still a truth. Sir?
Like, why is it equals to 1?
Can you say a little bit louder?
Like, why is it equals to 1?
Why is what equals to 1?
8 times x minus 3 plus b.
Okay, yeah, sorry. So I'll use some colors to help you. A times x minus 3 doesn't equal 1. Oops. This one right here is this one right there. And this is this. Another question to go along with that is, in this line right here, where on earth did the b go? Because the b just seems to have totally disappeared, right? Where did the b go? It got multiplied by 0. That's right, because 2 minus 2 is 0, and 0 times b is 0. What's that, Forrest?
I feel like everybody is smarter than me. No, everybody is smarter than me.
No, that's not even, whether that is or is not true, it's not even worth the time to think about. Let's just keep pushing forward and help you. What else can I answer for you?
No.
I didn't line things up very well. I get that. I can see why you thought that the 1 went with the a times x minus 3. Does what I wrote up there with the colors make more sense?
Yeah.
Okay.
I'm right there with you.
Come on, keep going. Questions, Meg. Go ahead.
So are we just assuming that it's continuous then? Like if you plug in any x, like how can you plug in any?
I don't think we have to assume continuity.
Because isn't an integral
It's like-
require continuity?
So say again?
Doesn't an integral require continuity on
It does. On the closed interval, actually. We're going to deal with that later on this unit. There's some interesting things that come about because of that. So Meg, yeah, I feel like you're kind of asking a similar question to Jack. You're kind of questioning like, how in the world can you just like plug in a 2 for x,
Well,
right?
like if it wasn't continuous, like if it was like a whole lot x equals 2, like it doesn't even equal x equals 2, so how would it plug that? I don't know. Just need to plug it in.
Are you referring, when you say that, are you referring back to the fact that there appear to be some vertical asymptotes at 2 and 3?
But also, yeah, that, but like just, like now I get that those numbers worked well and how you got that, but I'm saying like in general, like if we just get a problem like this, how do we know that it's
So let's see here. I wasn't planning on you guys asking this, just from a partial fraction decomp perspective. So, like if you have an equation like this, like I feel like you're looking back over here and you're saying, yeah, but look where it came from. Am I right? So just think for a second on this level. If I just gave you this equation right here, I should have used my fancy rectangle tool, but I didn't. How could you argue with someone that said, hey, I want to plug in a 5 for x? As long as you do it in both places, who might argue with that? I want to plug in a 2 for both x's. I want to plug in a 3, a 7, a 9, a 10. As long as you plug the same thing in for both x's, you have not violated any rules at all, right? So what we are doing here is we are trying to figure out what would these fractions have been to get to that integrand, right? And so when I look at this equation, here's my fancy rectangle. When I look at this equation here, I think to myself, if I want to figure out what the a is, I need the b to go away. Otherwise, I have too many variables, right?
Okay.
So the way that I get the b to go away is to multiply it by 0, and the way that I get the b to multiply by 0 is to plug in a 2 for x.
So basically, if you were on a test, you would set like the input thing for b, like the x minus 2 part, you just set equal to 0. So you.
Sure, and that would say x equals 2, and that'd be your first number to plug in. Yeah. It might be, so I'll get your question in a second, Julia. It might actually be helpful to see where we go with this. That might actually help answer some of your questions, because all we're doing is we are taking an expression and we're just changing its form. We're not changing the value. We're not changing the fact that there are some vertical asymptotes in this. That's not going to change. We're just trying to change its form. We haven't found any antiderivatives yet. We haven't arrived at any sort of an answer yet. We're just manipulating something. I might have some better analogies here in a second to show you, but let me finish it. Go ahead, Julia.
So if it was like the first one, when you plug in x equals 2, let's say 1 was equal to like a of 2, would a then be 2?
No, you divide both sides by 2, and you get a equals 1/2.
1 1/2, okay.
We'll do something like that here in a little bit. Well, let me do this really quick. So this is going to be my key to rewriting this in a better way. I've gone through, I've plugged in some numbers, and I found out that a is -1 and b is 1. So what I can do then is I can come back over here and rewrite this with -1 in place of a. So it would be -1 over x minus 2 plus +1 over x minus 3 dx. So I'm taking this expression in purple and I am importing it over there using my values for a and b. And really, if you think about it, aren't I really just replacing this with this? Why am I allowed to do that?
Because they equal each other.
Because they're equal. And how do I know they're equal? That's how I set it up. That's how I set it up at the start. I said 1 over x minus 2 times x minus 3 equals some unknown number over x minus 2 plus some other unknown number over x minus 3. Another way to think about this, like I think I mentioned this a little bit earlier, is we are basically trying to break apart a common denominator in adding situation. So think about it like this. This is going to take you back to like algebra 2. You ever remember seeing something like this? Simplify -1 over x minus 2 plus 1 over x minus 3. Remember these rational expressions? Yeah, so in order to add these, you need a common denominator. And to get the common denominator, it doesn't need to be the product of the two denominators. So let me give myself a little bit more space. In order to get a common denominator, wouldn't I need to multiply top and bottom by x minus 3? And what would I need to do over there with that one? X minus 2. So it'd be times x minus 2 times x minus 2. And then you go through all this, you'd get, negative x plus 3 plus x minus 2, all divided by our common denominator. And what does that numerator end up being? 1, right? So this equals 1 over. So my point for showing you this is that what we have done with this partial fraction thing is we've tried to take what you did in algebra 2 and start with your finish and work our way back to your start. We're trying to undo what somebody previously did. Let's pretend some algebra 2 student. Let's call him Timmy. He went and he added some rational expressions together, right? He went and he added the two black expressions together, and he got all the way to here. And he said, hey, I did it. I found the sum of these two fractions. What are we doing? We're taking Timmy's work and unraveling it back to what he started with, because it's going to be in a much easier to use form for us.
Because Timmy's in algebra 2.
Timmy, that's why he keeps messing up the chain rule stuff.
Wait, so does that mean that there's going to be things that are messed up with it?
Um,
Or not fixed?
we, every now and then, I suppose, but they'll be easy to see at this point. So check this out. So with this, oops.
It's gonna be okay, man.
Yeah, Meg, I think you're really stressing. I think you're really redlining, and I don't think you need to be. So let's just take this let's just take this new version of our integrand and let's take it for what it is, right? I'd break this up and it would be negative 1 over x minus 2 dx plus the integral of 1 over x minus 3 dx. The second one is the easier of the two. What's the antiderivative of 1 over x minus 3?
Isn't it negative ln of x squared?
I'm doing the second one first.
What, sorry? Oh.
It'd be, yeah, natural log, absolute value of x minus 3. What do you guys think the first one would be?
Negative ln of x minus 2.
Yeah, negative ln of x minus 2 plus c. So Meg said, might there be some Timmy messed it up things? Well, yeah, maybe if it's like 1 over 5x minus 2,
Am I missing 5?
off by a factor of 5. So like the fixes will be fairly simplistic, like what you're used to at least. Is this making sense?
Yeah.
Okay. So there's the potential for a little bit of manipulation here, some rewriting. Would you guys agree that this would be a very trivial rewrite? Couldn't I just change it so that I have a positive term minus the other term? I could just switch the order. But then what follows could be a not so trivial rewrite. How could this be condensed into just a single term plus c?
ln of the absolute value of x minus 3 over the absolute value of x minus 2.
Division.
Plus C.
Division. Don't forget the plus c. That's right. So it'd be ln of the quotient of those two inputs plus c. So just a heads up that could be a thing that you would see, say, on a multiple choice. 3 response, I'll take any correct form.
What about the negative?
So when you're subtracting logs,
Oh, right, sorry, yeah.
you condense by division of the inputs.
Yeah, just like
positive
miss it
and
for a
minus.
second, and then we try back into it.
Okay, so maybe we should get some more practice for sure, especially on this partial fraction part. So let's move on to number 2. Please check that out. There we go. Okay, so very similar to what we just did. Please try this one. I'm going to put the factoring up there just to make sure we're all on the same page with that. So it should be good. If we write them a little bit differently, our A and our B at first will maybe seem like they're different, but then based on the fact that we wrote them differently, it'll work out just fine.
Okay.
So that, yeah, there's no magical way as far as ordering goes. We would just have like a different A and a different B, but then they'd go into the different spots. They'd switch,
Okay.
as we'd end up with the same result.
Okay.
Yes. Watch us both if you're wrong, that'd be so funny. I would not put it past us either.
Okay, so this is my setup, and I know talking to Julia, we set it up slightly different, right, with the A and the B. The truth is, it should work out the same in the end, right? So this is how I set it up. Once I do my multiplication, I end up with 1 equals A times 2x plus 1 plus B times 2x minus 1. This is now set up for me to be successful with solving for A and B. Do you guys plug in either a 1/2 or a negative 1/2 to accomplish that? Okay, so I'll say if x equals 1/2, then I get 1 equals, what is this, a times 2? Yes? So it'd be a times 2 plus 0. Therefore, I got a equals 1/2. You might have gotten a equals negative 1/2, but we might have switched the order of things, and that's okay. And then if x equals negative 1/2, this would give me a times 0, so 1 equals 0, and then it would be negative 2 times b. So did you guys get something like this. And again, your positives and negatives might have been switched on the A and the B, depending if you set it up the same way as me. If you didn't set it up the same way as me, then they probably would be switched, right? Okay, so I'm going to come back over here and rewrite this as the antiderivative of, this is where we should start agreeing, right? It would be 1/2 over 2x minus 1 plus negative 1/2 over 2x plus 1. Let's say at this stage we should fully agree, right? Just because our A's and our B's are switched. Yep, exactly. So then maybe I just take a quick second and rewrite the whole thing as the sum of two different antiderivatives. So it'd be 1/2 integral of 1 over 2x minus 1 dx minus 1/2 integral 1 over 2x plus 1 dx. This is where Meg's worst nightmares are revealed. Timmy messed it up. We have to make an adjustment. Both factors are the same, right? Didn't he mess up by a factor of 2 in both cases? So I would go times 2 times 1/2 times 2 times 1/2. So one version of a final answer would look like this. 1/4
What did you do? How did you?
natural log 2x minus 1 minus 1/4 natural log absolute value 2x plus 1 plus c. Was there a mess up?
Yeah.
What'd you mess up on?
I said like A, instead of like having that input be 2, I had the input be negative 1/2, so it equaled -2.
What do you mean?
What do you mean by input? Over.
Not input. I don't know.
Over. Are you talking about this over here?
X?
Are you talking about these guys?
That right. And then you said that A of negative.
No. Look at what you did.
Are-
I
are-
don't have you up there.
That's what I.
Are you referring to this right here, Megan,
No,
in the
this-
blue,
no.
in the blue rectangle?
No.
You had that. You had that. Yes.
Yes.
That
I'm
part.
talking about A in parentheses 2. I put A in parentheses negative 1/2
Oh.
equals 2.
That's a tricky one.
Okay. Do you see why that makes sense or no? What I have up there? Maybe not. Let me talk it through with you.
No.
So if x, let's just focus on this line right here. If x equals 1/2.
Yeah.
So if x equals 1/2 right here, don't you get 2 times 1/2 is 1, and 1 minus 1 is 0? Hence, b times 0 is 0. That's why the b seems to go away.
Yeah.
Right here, though, if I plug a 1/2 in there, I get 2 times 1/2 is 1. 1 plus 1 is 2. That's where I'm getting this a times 2.
2 plus x and then into the equation.
Yeah, you're literally replacing the x with whatever number, in this case 1/2, and then doing some evaluation to actually find the value.
Okay.
And then to go from that step where I have the 2 circled, I'm just going to divide both sides by 2.
I don't know what you did.
So let me put it like this, Meg. So like this equation in the blue box would be like if I gave you 1 equals y times 2. How would you solve for y?
Just divide both sides by 2.
And that's all we're doing. That's all we're doing to find the a. I think it feels like it's way more complicated than that.
There's 1.
There's a 1 over there. Yeah.
Really
what I was
long
laughing
time.
at.
Make this one 1.
I feel like the light bulb just came on, right? Okay, cool. Anybody else have a question or?
That's what I was laughing at. I was like, what did you do?
There's a 1.
Did you lose your equal sign?
No.
Did you
She
have
wrote
blank
it-
equals?
No, I got
She wrote-
everything
she
right.
wrote it down.
Okay.
She wrote it down.
So your hand knew what was going on, and okay, gotcha.
Oh, wow.
Gotcha.
It was special, Meg. So my thing was.
It's okay.
And so
It's okay. I have those days sometimes too.
Multiply the outside of
Santi.
If the coefficients of the LNs weren't equal, how would you combine it?
Well, you could move them up and make them exponents, perhaps.
Oh gosh, that is.
That'd be the only thing you could do.
What was it for?
So would it just be like 1/4 ln of 2x minus 1 over 2x plus 1?
No, it'd be ln of the absolute value of 2x minus 1.
Yeah. To the 1/4 power or times 1/4, depending on what you want to do
But
with
it's the
1/4.
but it's the ln of all of that. It's not,
Yeah.
It's not the totality to the 1/4. It's the inside.
Yeah, it's ln of input to the 1/4.
Wait, so I could write it as
Yeah, you could totally do that because, and that's kind of what, sort of Santi's point is that because those 1/4 are the same, you could essentially factor them out, condense your logarithms, and then multiply the 1/4 back in.
Gotcha.
Yeah.
My
You
way
could.
actually worked. I did some pretty cool stuff.
And at what?
I got the answer.
Is it valid though, right? We want to
No,
know.
it'll
Okay.
never work again.
Okay. Fair enough.
But I got it.
Hey, the good news is we got a couple more shots at this. Let's try. Let's try number 3.
And we believe in faculty and I'm so happy.
Veterans, I know this is a foreign feeling of like, it's new. And so
We actually have to learn stuff.
Now you know.
you might not leave class like having it like totally mastered. I mean, maybe, hopefully you do.
Now you know what it's like. how
You're
I
like,
felt.
finally
That's
they
like a
know.
month and a half.
Yes,
No,
yes.
no, this is-
For them, it's just like they magically seem to know it. And you're like, well, wait, what? Hey, example 3, please give it a shot.
But see, now I'm not ready. I just said I feel great, and I said it.
So Sam, if you wanna try to finish this by yourself, just try to shut me out for a second here. So here we go, guys. Let's wrap up and let's hopefully happily confirm that we know what we're doing. So Forrest, you were pretty vocal here. Do you want my help?
Yeah.
Okay. Y'all okay with this? Factoring?
Yeah, I like that.
Okay.
That's nice.
So I'm going to come over here. I'm not going to freak out because there's x's in the numerator now. I know it's tempting. I'm going to write this out exactly the way that I have before. I don't know if you guys put the x plus 3 and the x plus 6 in the same order. I did, but I did something like that.
But it's not 1.
Doesn't matter. Doesn't matter. All I'm trying to figure out is, hey, someone added some fractions together, and what I'm trying to figure out is, how do I break them back apart? So just because that numerator is a non-constant, doesn't matter.
We know that it's possible because you made it possible by setting it equal to it.
Yeah, if it's going to be possible, we're going to find them. Right, that's right. So Forrest, what I would do now is I would multiply through by the least common multiple of all the denominators. This would give me 2x minus 3 equals a times x plus 6 plus b times x plus 3. And this, of course, is a little bit different than what we've been doing because there isn't a 1 on the left side, but it's okay. We're not gonna panic. We're gonna just try to proceed and see if it still works. So we're not gonna panic. Are you guys okay if I say x equals -3 for my first effort? Okay, so if x equals -3, I've got to plug it into 3 places. Here, here, and there. So when I plug it in on the left side, I get -9. So -9 would equal 3a. And how do I get the a by itself?
Just divide by 3.
Division. So a equals -3. That is my first partial fraction coefficient. You see, it's a pretty smooth process, right? We don't need to get too hung up on what's on that left side. If they're non-repeated linear factors, it should all go pretty smoothly. And then what would be the other number that would make sense to plug in to get the b value? -6 would make sense. There we go.
Not gonna lie, I was on that for a second.
So this gives me -15 equals -3b. So then division tells me that b equals 5. All right, so there's my other coefficient. Notice there was no need to panic with the x over there. We just plug in where we go and see what happens. Turned out really nice. Okay, so to finish this one off, I can then replace that original integrand with this plus that. And if you were just curious and you doubted it or something, couldn't you take those 2 fractions, get a common denominator again, re-add them together and see if they really did equal that original? And I think you'd find that they probably do. Okay, so then as kind of a final answer here, y'all see that, have you figured out that there's going to be a bunch of ln's with our partial fractions? There's going to be a bunch of them. So this will be -3 natural log of x plus 3, absolute valued plus 5, natural log of x plus 6, plus c.
This could get so nasty with like non-factorable quadratics.
Totally.
Squared bases.
Yeah, x squared plus 6. go, right?
This would be so much.
All these things are doable, and you end up with all these different. You end up with some non-LNs.
Plus tangent.
So
and
X
stuff.
Yeah, you get some arctangents. Totally right. But because we have the non-repeated linear, we're not going there. That's okay. Yeah. That's about all the time we have. We've got like a minute and a half left.
I just learned so much.
New stuff.
This is like,
Yeah, my brain's like full now.
this is crazy.
Well, let that digest, and we'll learn more stuff later on, including, let me just plant this in your mind. Later on, check this out. Later on, you're going to look at stuff like this, which, you've seen stuff like this before, maybe from like 3, but now it's going to be to infinity.
Wait, why?
That comes way later.
Mr. Emerson?
The question is going to become, how could this possibly be anything other than infinity? But it could. It gets fascinating real fast.
Like all the
Wait a
derivative.
minute.
I know. Wait a minute.
That makes sense.
I know. It's very
Skip
interesting.
that unit?
We'll get there. That's this unit. We're already in it, Sam. I'm sorry.
Oh, no.
We're going to finish it now that we started it.
That's this one.
All right. See you guys. Have a good day.
You should just make the quiz into a test and
Just
stop.
love sign.
Say again. Oh, yeah. I will do that right now.